You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Podcast. I'm your co-host, Dan Blewett. On today's episode, we're going to cover first in our news section, families are urging EASA not yet to approve the 737 MAX, even though it seems like a return to airworthiness is obviously right up upon the European Union. The 737 is back in service in the U.S., but families are still urging, so we'll talk a little bit about that today. The EPA is finalizing the first ever airplane emissions rules, which sounds like a good thing on the surface, but Alan's take here, I think, is a little bit, not surprising, but it's an insider's take, and so we'll chat a little bit about why EPA emissions rules for airplanes might be a little misleading and maybe not be the best thing, all things considered. In our engineering segment, we're going to talk about Pratt and Whitney engines. There's a new factory in North Carolina, and their GTF engines have gotten really high marks on reliability. So we'll chat about some of the technology there. And lastly, in our EVTOL segment, we're going to talk about the new FAA drone ID rules. So these aren't, these are obviously EVTOLs, but not in the traditional sense that we talk about in most of our episodes. But this is a really interesting thing, and it's going to be important as drone capacity increases in the airways. And lastly, the Airbus drone VSR 700 is getting pretty close to landing on Navy ships, which is apparently a pretty interesting feat of engineering. So, Alan, let's start with EASA and these families over in Europe who are urging the certification organization to delay the re-entry of the 737 MAX. So is this pretty typical after crashes like these, after a safety situation like this, or is this is it atypical?
It's more and more common, I would say, that families take more legal steps against the aircraft companies and against the certification authorities to speak and saying that they have a say in the certification process and are trying to push additional, what they would believe to be additional safety measures onto the aircraft. The one in particular is they would like to see a third angle of attack sensor used on the 737. The latest update from all the safety reviews is that they've added a second AOA, or they cross-compared the AOAs that they have on the aircraft right now. So that if there's some dispute, one's not working correctly, it's going to flag it. It's going to therefore disengage the MCAS system, the updated MCAS system. But they think they ought to have a third one there as a compare for the other two. And there's regulations set up about that, about the reliability of that system and what the failure modes are, and the families just disagree. Now, will that stop EASA from moving forward? I don't think so, unless there's some political reason to use the families and leverage that to delay the start of the 737 MAX in Europe, which they could clearly do. But I think on the certification side, I don't think there are any hurdles besides essentially pilot training at this point, and what that pilot training looks like, and how many hours of training that looks like, and how is that going to be accomplished, and is there any other pilot related issue that the EASA or the other certification authorities want to address as the door is open right now? Because once the door closes, everybody goes off and starts operating the aircraft. It's going to be hard to undo that. So we'll see what happens here. It's really hard when you have families involved. They don't know a lot about aircraft design, probably. And so what really happens, you have lawyers, and from watching this a couple of times, it's part of a larger strategy, probably, unfortunately, in lawsuits. So if they get the certification authority to disagree with the latest update to the 737, does that help them in court for lawsuits? Probably does. So let's see how this one plays out. It's just really unfortunate because both things have to happen. You're going to have the lawsuits. You're going to have that play out through the court system. It's just going to play out through the court system. But at some point, 737 has been around for a long time. Is it really all that unsafe, or is it just this one system? Is it just this one system because they're having problems with the angle of attack sensor? or pilot training. Who knows? But I doubt this is going to push the 737 back too far in Europe. I really doubt it. I think they're pretty much there right now.
Yeah, well, and they also called into question the FAA's decision, read the Senate committee's report. So they're like, hey, this report just came out and it was pretty ugly. So are we sure we want to go ahead and do this? Which I guess that's a valid point of view. And it is a little strange, considering like, this plane's back in action. We're all good to go. Like, the FAA's sort of said, we're fine. And then the FAA is coming in after that, angrily scolding them some more. That I do find the order of operations there a little strange. Obviously, the Senate report had nothing to do with recertification with the FAA.
No.
But like I said, it's like you build a house and you're done, and then someone starts pounding on the door about how unsafe it is.
Right.
It's like, well, everyone else signed off on it, so what are we doing? But yeah, I understand. There's a lot of emotions and there's a lot of complexity to what's going on in the court system with the families, and it's a tough situation for everybody, I'm sure.
Yeah, it is.
Just to say, it's almost like you're releasing this, almost like you're releasing a killer from prison. I don't know if that's really the right way to put it, but that's maybe how it feels a little bit to them. Like, this took family members from us, and you're letting it back in the wild. Like, are you sure? So, like, I get that.
Yeah, I get it, but I feel like I'm always I'm on the side of the FAA way too often here. The FAA is doing a very, very difficult job, and they're stuck in the middle between politicians who can kick them all the time and the industry, which is trying to satisfy them. So you're kind of in this, at the FAA, you're in this like no-win situation. At the same time, your goal is to improve air traffic and air safety, right? And no matter what you do, there's always going to be some problem somewhere in this big world of ours and all the airplanes that are flying today. There's always going to be some aspect which isn't going as perfectly as someone else would want it to be. But I think at the end of the day, the FAA has been doing a really good job for a long time. It doesn't mean that they can't make improvements, but gee whiz, there's a lot of positive things that are going on in aircraft safety. And if you watch over the last 10, 15 years, there's been really remarkable steps and increases in aircraft safety and performance and all the other things we're going to talk about today. Those are only possible, really, with having a functional FAA that can work both sides. So, yeah, it's tough. It's really tough.
So moving on, the EPA is about to finalize emission standards for commercial aircraft that are either large business jets or commercial airliners. And critics are saying that these standards are not tough enough, that they're going to be quickly outdated. And of course, these are the first ever compliance rules. But Alan, your take on this is, I think, a little unorthodox because you're an aerospace insider. Does the EPA have business regulating airplanes? Now, we know that they do cause a lot of emissions, but you're saying that they've been reducing emissions for many, many years now. Is that trend going to continue, and is this really necessary?
The aircraft industry in general has been reducing emissions and increasing efficiency dramatically since the start of aviation. That's the only thing that they have done consistently is aircraft have gone further, faster, with less fuel burn, and taking more passengers per gallon of fuel than ever. And it's just been a steady progression in that direction. And I know we're going to talk about the geared turbofan from Pratt Whitney, which is another huge leap of innovation. Why are we kicking the aircraft industry? Because it is set up fundamentally to use less fuel to get more passengers moving more miles. That's the ultimate goal. If that's what all the electric vertical takeoff and landing aircraft are all about. And I know this doesn't obviously apply to them, but essentially, without the EPA, the industry is moving in the direction you want it to anyway. It's going to naturally because there's the cost of fuel is such a big player in operations of aircraft that any significant improvement in terms of aircraft involves engine efficiency or aircraft efficiency. It's just natural to the system. So why do we need this external force poking it and making it difficult? I don't understand what people go to bed at night thinking, well, the EP has passed a rule, therefore the world's a better place. That isn't what happens here. What happens here is that there's natural market forces that play into the design and the development and the operation of aircraft, which force it to be more efficient naturally. So at what point do you say EPA steps in and essentially, in theory, I think in theory, by 2028, depending on the size of the aircraft, your aircraft could be banned on some level? Because it's a little vague when you read the articles. It's a little vague, but if I own let's say I own an older Gulfstream aircraft, like a G2 or G3, in 2028, does that aircraft need to be re-engined? Because that's not the cheapest thing in the world to do.
Yeah, a couple $1 million, right?
Right, so it just makes my aircraft value go probably to close to zero immediately if I can't, because probably won't be able to sell it. It's like in California, I think there's restrictions on what kind of vehicle you can purchase in California based on the environmental regulations there. You can't bring in a car, and I don't think you can bring in a car in from the outside necessarily and operate in California if it doesn't have the emissions equipment to operate there. So you're kind of setting up that same situation in aircraft, which has really never been there before. There's been noise rules for a long time, but that's been grandfathered. A lot of it's been grandfathered. But the carbon, essentially the carbon dioxide emissions are going to be monitored. Why? What purpose does that serve? I think 3% of carbon dioxide emissions come from aviation. The vast majority of those is probably on the like the Airbus, Boeing type aircraft, right? The business jet can't be that much into that mix, I wouldn't think. So what are we doing? Are we going to crush industries that already exist, that are already working towards better aircraft? Or are we going to what is the point? I just don't understand the point right now.
Now, is this maybe just like a ploy to get, manufacturers to start moving towards hydrogen engines a little faster? Is it just sort of like to start to maybe box companies like Pratt Whitney and GE in a little more to say, all right, well, maybe it's time to just abandon traditional jet turbines as it is and just like really start to put more money into hydrogen fuel cells? Or you think it could be anything like that where they're just sort of negotiating with a standard like this?
So yes, you're picking winners and losers. On some level, you're picking winners and losers. And I don't think the government has a very good track record of doing that. Now, if you want to talk about a hydrogen system, awesome, but there's a lot of technical hurdles that are going to be involved in that. 2028 isn't nearly the amount of time for that to happen. That will not be done by 2028. The other types of technologies that could be forced on the industry are not developed either. And there's a lot of different, from biofuels to the power of X systems that we're talking about in terms of creating fuel from the air, and there's just a lot of different ways to answer the question. Obviously, everybody in engineering knows that we want to have less emissions. We live in the world too. Why wouldn't we want that? But there becomes certain limitations, particularly when you're introducing a new technology. You may be making the aircraft less safe. So are you okay with more crashes because you have a cleaner, quote unquote, a cleaner environment or less CO2 in the air? That's the kind of trade-off we're talking about here. And there's no engineer worth their salt that's going to say, I'm willing to kill people to make a 0.001 decrease in carbon dioxide emissions. That ain't going to happen. So at some point, you got to get to the real part of this, which is Boeing and Airbus aren't not going to play around. If they can't deliver an aircraft, then they have the might in Europe and the United States to stop whatever regulation that exists or would exist, right? So obviously Boeing and Airbus have blessed whatever's about to happen. The larger aircraft companies like Gulfstream, Bombardier, Embraer must agree to this, because if they didn't, they'd be fighting it tooth and nail. So on some level, the aircraft industries have probably bought their way into this regulation. But what are we doing to possible new entries? Are they restricting things we haven't thought of before? Because the aircraft industry is about 117-ish years old, roughly. And from that point, we've come from single pilot propeller airplanes to supersonic aircraft to aircraft that can fly literally around the world. A little over 100 years. That's crazy. But we've never really put these kind of odd restrictions on emissions before. because we don't really need them. I think that's the thing, is we don't really need those restrictions. The industry itself will go in the right direction. Just leave it alone, monitor it from the outside. There are other places to go push for carbon dioxide emissions, and the United States has reduced carbon dioxide emissions over the last 10 years. There's been a decrease nationally in the United States. That's going to continue probably. What do you think?
I think it's that knee-jerk reaction. Yeah, I mean, everyone right now is able to have a voice, right, on the web. And so I think people are like, well, all the people who really love the planet, which is great. I'm not hating on loving the planet, but everyone's like, well, the airline industry, I mean, they're a huge part of the problem. Why don't we regulate them? This makes no sense. Why are they not getting regulated? It just seems like a quick knee-jerk reaction. But,
right,
to your point that aviation is really important for human movement around the globe,
yes,
much more so than, I don't know if we could say much more so than cars, but it's been a huge part of transportation around the globe.
It has. Well, you can't drive across the Atlantic. You're not driving across the Pacific, right? At some point, you need an airplane.
Not yet.
Right? We still need airplanes to go do these things, and to move traffic from Asia to the United States overnight. There's only one way to do that. So are you willing to give that up? And do you realize what the consequences of that mean? It basically means people die. That's what it means. It means it takes longer to develop vaccines. It takes longer for everything to occur. Are we willing to give that up for, like I said, a very, 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 very small fraction of CO2 emissions that are going to be possibly reduced by this? Doesn't seem like a valid trade-off, because there are consequences to these decisions. You need to weigh the costs and benefits here. Have we weighed the costs? I don't think so. Like
I said, it seems like people just like, well, why shouldn't everybody? That's not fair. Everybody should be regulated. If cars have to, then planes should have to. Well, like you said, it's more complex than that, and I don't think a lot of people would realize it. I wouldn't realize it if I was just reading this and weren't given your knowledge on a weekly basis. Like, I wouldn't know. I'd be like, oh yeah, that makes sense. They're a big contributor. They should be regulated. Done deal, right? But when you're an outsider, it's easy to say that.
It's easy to say, yeah.
All right, so moving on to our engineering segment here, we're going to talk about Pratt Whitney. So their GTF, their geared turbofan engines are powering, looks like about 900 aircraft right now. They have a new factory in North Carolina. And so the A320neo is powered exclusively by Pratt Whitney GTF turbofans. The Airbus A220, the Embraer E-Jets E2, and Pratt & Whitney, which is owned by Raytheon, they're touting that, just again, which we were just talking about, they've saved more than 400 million gallons of fuel and over 3.8 million metric tons of carbon emissions. So like you said, they've been doing this unregulated. They've been doing it on their own because they just want to make more fuel efficient aircraft so that they can save money, be more profitable. Sell. I mean, it all makes sense, which is just very different than, a car, because you can get from point A to point B in a car and no one really cares.
Right.
If you're guzzling 10 gallons of gas, but when your business depends on reducing fuel consumption because it's getting so expensive, it makes a lot of sense to just start, hey, how can we be more fuel efficient? And as we talked about in an earlier episode, like, planes and airlines have been swapping out engines to do this. So like, hey, let's get those more fuel efficient engines. No one's telling them how to do that, or that they have to do that. They just want to do that. So what's unique about the Pratt Whitney GTF series? Because they're seemingly a pretty unique turbine engine.
Yeah, the sort of fundamentals of a turbofan engine. You got this gigantic fan on the front, which is what they call the cold section, and then you have this sort of hot jet engine section behind it. That fan that you see when you get on an airplane, if you look in the engine inlet, you see that big fan in the front. That fan is actually driven via a shaft as part of the jet engine inside. So the back end of the jet engine is shafted all the way to the front to spin that fan. So we've, just sort of part of jet fundamentals here is that the more efficient you make that fan in the front, the more efficient your engine is. The problem is with the general layout is the hot section back in the back of the engine wants to spin at a certain speed to be very efficient. And for the front fan to be efficient, it needs to spin at a slower speed. That's where the gearbox comes in. Now, from an engineering standpoint, and on the back of an envelope, you go, oh yeah, if you can basically put a transmission in this engine from the hot section to this cold section out front, you can get a lot more bypass, or a lot more thrust, a lot more efficiency. And you also know that when you put more cold air, which you have a larger fan up front and it's moving more mass, it's not moving it as quickly. The fans aren't moving as quickly, but they're moving more mass of air with every sweep of the blade. That air, when it runs back over the hot section of the engine, makes the engine quieter. So you got this double effect of reducing emissions, noise emissions, but also having a very efficient thrust system. The problem is that transmission has to handle thousands of horsepower and be reliable for 20, 30 years without ever breaking down. So to create that transmission in the middle of this engine was always the problem. That because of the complexities of that system and how reliable it had to be, particularly on twin-engine aircraft that are flying over water, for example, you can't have that section fail. And it was basically quasi brand new technology. And Pratt and Whitney struggled with that for a long time. I know they had worked with NASA to develop parts of it and to come up with some of the conceptual pieces of it. But Pratt and Whitney put essentially their engine company on the line for a long time to develop that transmission section, the geared turbofan. And they had problems. Early on, they had problems with that engine because of the complexities of it. But like most engineering projects, if the physics and the fundamentals are right, you can kind of work through the details. And once you develop the wherewithal materials and all of the engineering improvements, particularly because you can machine things so finely today, you can make this transmission. So the numbers tossed around, I was watching a little Pratt and Whitney video talking about this, what the fuel savings were per airplane per year. It's about $1 million a year in fuel cost reductions using these engines. You're like, wow, $1 million per year per airplane. That's a lot of money.
Yeah. $100 million for a Southwest fleet. I mean, I don't know how many planes Southwest is flying, but
yeah, I mean,
quite a few, right? A couple hundred? I don't know.
Oh yeah, a couple hundred, right? Yeah,
$300 million savings. Yeah,
right. So the it's A320neo that has these engines on them. Very popular airplane today because of the fuel burn, right? They had some trouble early on, and I think they ended up grounding a bunch of Neos early on because of I think there was issues in the hot section with it, not necessarily with the geared section. And Bombardier had trouble early on the C series, which is now the A220, with some oil retention issues. But they've worked through those issues, and it looks like that technology is going to be the way to go forward. And you're going to see the other engine manufacturers develop something like it. Whether it comes to market or not, we'll see. But that is an engineering marvel. It may seem simple when you're sitting in the airplane looking out on the engine and go, oh, new engines. But it took Pratt and Whitney literally 20 years to develop this thing. And we just take it for granted, right? We just take it for granted. We get on the airplane and they don't think twice about it. Meanwhile, people's whole engineering careers were working only on that.
That's crazy to think about.
Right? Yeah, exactly,
Yeah.
Right? So when we talked about the EPA controlling or putting regulations out, you think you could just wipe out people's whole lifetimes with that. Because it's a huge risk for Pratt & Whitney. It's a huge risk. If you look at the articles that were written 10 years ago about the geared turbofans or 15 years ago, like, this is impossible. This is going to be the downfall of Pratt & Whitney. Pratt & Whitney can't afford to keep paying money into the system. This is never going to come to fruition. Yeah, it was a huge risk because no one had ever done it before. But now that's been in service for a little while, and now we're finding out the reliability is pretty good and that we are making those fuel savings that we thought we were going to make, and everybody's starting to be happy with it, and the industry will change over time into those type of technologies. We're going to be able to squeeze engine technology to places we never thought possible because it didn't have the skill set to go do it. And now that we've shown, what Pratt & Whitney has shown, and NASA has shown, and some others have shown that this is possible, it just opens the doors to other type of fuel burn savings. And this is a remarkable feat. I don't know if everybody gets it, but this is a remarkable feat. And we just take it for granted. Super frustrating.
Alan, are you getting choked up? Are you going to shed a tear for this?
Well, it does. This is the thing about aircraft, right? When you decide to work on an aircraft program, you pretty much kiss away 5 years of your life. Straight up. Maybe 10. So by the time, if you start on an aircraft program, a new aircraft program like it's in development, it's not publicized and you're back in the back and you're working on the design on a clean sheet of paper and you want to ride this thing out to the end, you're going to eat up a considerable part of your life doing it. And so if it doesn't come to fruition, kind of seems like a loss, doesn't it? And I've been on a couple different aircraft programs that never came to fruition, and it feels like someone stabbed you in the heart. That's what it feels like, because you know that aircraft could work, but there's a lot of variables there. The economy being one of them, the government being another one of them, and to lose the ability to bring something to market that probably should be there is really tough to swallow. And when things like this, where Pratt Whitney basically makes a miracle happen, we just don't give it the recognition in which it deserves, I think.
All right, so in our final segment here, we're going to chat quickly about a little bit of eVTOL news. First, let's start with the Airbus VSR 700 drone helicopter. So this sounds like another one of those same projects, Alan, that you said it's been historically very difficult to land something on an aircraft carrier, like you're landing on a moving target, right?
Yeah.
So they have these moving deck systems to simulate the movement, like the roll and the pitch of a ship at sea. But Airbus is apparently getting pretty close to having a tactical unmanned aerial system with autonomous takeoff and landing. There's an article from Aviation Today, being able to land on one of these flight control decks. So this sounds like another one of those really long problems.
It is.
But it sounds like it's getting close to coming to fruition.
It is, because the computational ability we can shove into an aircraft of any size is getting so complex and capable. I always relate this to the autonomous driving car. If we can have a car drive itself and safely down the road, see stop signs, see speed markers, all that stuff, that same level of skill set can also be applied in aviation. And when you're trying to land a moving aircraft in the wind and in turbulence on a ship that's moving up and down, left and right, that's one of the hardest control law problems to solve, because weird stuff happens. And so they've been working on that technology for a number of years. A lot of companies have actually been working on that kind of technology for a number of years, because it has applications all over the place, life-saving applications, actually. So to see that Airbus is progressing with it is really good, because it's, again, one of those engineering problems that needs to get solved. It's kind of like SpaceX landing their rocket back on a pad on land, right? Yeah. But first, I guess they landed it on a ship, right? So the SpaceX group has kind of worked that problem a little bit, but they all had a bunch of failures early on, and any aircraft company is going to have some failures early on, because it's a very difficult problem to solve. It's one of the harder control problem laws to solve and do it reliably. And that's what we're talking about. So I do think this is a big advance. They will get it. It's just going to take a little bit of time and proving it out, because it's not that you can do it once or twice, or like the SpaceX thing. If one of these rockets tips over and falls over and explodes, it doesn't seem like SpaceX even cares. But if one of these helicopters tips over on an aircraft carrier full of sailors and airmen and hurts somebody, it really matters, right? So there's just not a lot of room to move on a ship. If one of these things goes wrong and this helicopter lets go of a rotor, someone's getting hurt, right? So the safety is the utmost importance in the design.
And so last topic for today, speaking of safety, the FAA has released final rules for remote ID, which is going to control drone operations over people. And so basically all these drones are going to be forced to sort of register with a digital license plate that's going to project an identifier, so they can be easily ID'd by officials if someone flies it near an airport where they're in no fly zone airspace. Right, I'm here in DC, and you can't fly a drone anywhere within 25 miles of Reagan Airport. It's the most restricted part of the country. So they're now going to have a very easy way of knowing if you break those rules. And of course, a lot of drones like DJI, and I think this is probably most of them, won't let you fly. Like, they won't take off in restricted airspace. Like, I own a drone, it will not take off.
Right.
Since I'm within that airspace. So they do have some controls now, but obviously people are very tech savvy who enjoy drones, some more than others. Yeah. I'm sure they can hack that system and change it, and or just build their own drone, right, and go rogue. So obviously we don't talk about like consumer handheld drones that much, but it's a really popular thing. It's growing in popularity, and there's going to be more and more encounters with people flying these around places where a plane could be, or just injuring people. Obviously, Amazon is hoping to deliver packages by drone at some point. I'm sure other companies will follow suit. It seems like a reasonable endeavor.
Sure.
Potentially delivering medicine, to remote locations.
Sure.
There's lots of applications. So, Alan, does this seem like a reasonable step forward?
I think so. There's a local modeling club nearby, and I saw some traffic off of all things Facebook, which I rarely look at. But I was curious to see what the local modeling club was saying about that. And the comment on Facebook was, "Hey, these restrictions aren't as bad as we thought they were going to be. So we can probably get by with them." And I think at the end of the day, 99%, almost practically 100% of people that are owning and operating remote model aircraft or drones are doing it responsibly. It's that small fraction of a fraction that does something stupid, and then the whole lot gets tossed into things like this, where you got to now have a digital license plate. I did hear over the weekend there was a discussion online, I think it was on YouTube, where they're talking about a drone operator down in the Philadelphia area had posted a number of videos on YouTube of, I think he was operating around the Philadelphia airport, if I remember correctly. And the FAA saw those YouTube videos and sent him a bunch of fine notices for each one of those flights because he had posted them. I thought, wow, yeah. Who's watching at the FAA to make sure this is going on? And maybe YouTube's telling? I don't know. But it just seemed like, wow, there's a lot more oversight on what's going on with these drones than I thought there was, because I've seen a lot of drone video that looks wrong to me that's still on YouTube. And the discussion revolved around statute of limitations and when they could come get you or not. And the advice was, if you're going to do something stupid like that, wait till the statute of limitations pass before you post it to YouTube, which I think the better...
people don't follow those. Yeah, I mean, people have been recording themselves committing crimes, I mean, left and right, it seems like. It's crazy. But
yeah,
criminals aren't super smart a lot of the time. But one of the things that could be scary is that the idea that drones could be used for like terrorism, something like that. I mean, there's nothing, you talk about the Nashville bombing, you know, over Christmas.
Yeah.
There's nothing preventing someone from taking a drone, rigging it up to carry something, right? Amazon wants to carry packages. You carry a package full of explosives and drop it in the middle of someplace. That's terrifying.
You could do worse things than that. You could do a lot worse than that.
You could do a lot of really bad things. And so to have an easy way, and of course people who would do that stuff would obviously try to circumvent these remote ID rules, but regulation to hopefully ID these devices, these drones, is going to hopefully prevent some stuff like that from happening.
Yeah, I would hope so. There is just no going back at this point. As you know, the DJI drones are not that expensive, and the capability of them, like you said,
they're amazing.
They know where they're at, right? They know where they're at in the world, right? So you can't walk outside of your place and fly this thing because it knows it's in that radius where it can't fly. So it doesn't. I mean, how smart is that? I mean, but that just tells you how smart these drones and the systems are and how capable they are today. And I know on our wind turbine podcast, we've been talking a lot about using drones to inspect wind turbines. So there are very, very useful functions for drones, and we need them because it's taking people out of hazardous situations. We just, I think, got to stop the people doing the crazy stuff and putting people at risk, and we can move along.
All right. Well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.